This is the first in a series of videos that are designed to accompany the notes you've been given. The first thing we have to look at when we look at surds is quite simply, what is a surd? Now, you'll have come across surds before, but you probably won't have called them that. So, for example, the square root of 2. Now, if I asked you for the value of the square root of 2, you might be able to tell me, well, 1 squared is 1, 2 squared is 4, so the square root of 2 has to be somewhere in between 1 and 2, and you'd be right. You'd type into your calculator square root of 2, and out would come 1.41421335. And this would go on and on and on, and it would never repeat. And that's a very key aspect of a surd. It's a number that goes on and on and on, doesn't repeat. So, square root of 2 is a surd. Now, let's have a look at the square root of 4. The square root of 4, what times what gives you 4? And we have the answer of 2. Now, because this is an exact number, it doesn't go on and on and on, this is not a surd. Let's have a look at another one, the square root of 3. If you type this into your calculator, what will come out is 1.730250 ... And again, this is not going to repeat. So this is a surd. Let's have a look at the square root of a quarter. Now, your first reaction, what times what gives you a quarter? It might not be obvious to you. But the trick we can do here is we square root the top, we square root the bottom, and we find out the square root of a quarter is a half, which is 0.5. And that is an exact value. So it doesn't have to be a whole number for it to be an exact value. Here we've got a number that stops after the 0.5. It is exact. So this is not a surd. Let's have a look at an example of another number that will go on and on and on. You've got an 11th. So that is the same as 0.090900909. You can spot the pattern, and the fact there is a pattern in there tells you that this decimal repeats. It will always have 90909090 on repeat. So this is not a surd. Okay. Lastly, what if we had the cubed root of 3? Now, this is important. It doesn't have to be a square root. It could also be a cube root or a fourth root or a fifth root. The cube root of 3 is 1.44222495. It's not going to repeat. So this is a surd. Hopefully you'll notice what all of these surds have in common. So if we look at our list, you'll see the examples I chose to be surds. We have the square root of 2, the square root of 3, the cube root of 3. For it to be a surd, it involves powers and roots. So there are other numbers you know, such as pi, that go on and on and on and on, but they are not surds. Okay? For it to be a surd, you're going to have square roots, cube roots, or powers involved.